things moving. Our first talk is going to be results from long-term implementation of computational exercises in teaching a general astronomy class by Raymond Zich.
Well, good morning. Some of these results have been presented before. You may have seen some of this. I have an extension of data that we have been doing of this work. This started off with a lecture-based astronomy course that I had developed as a gen ed course. Covered standard astronomy topics. The mathematics level is algebra with a little bit of trigonometry, and it had the physics course prerequisite, which we sometimes waived. Okay. Didn't want to rip anything off. But there was no laboratory or recitation component to this course. The course was designed as a sophomore level course. However, I found that first year through fourth year students taking it were all successful, so we basically cover all the levels. There was a mix of STEM and non-STEM majors in the course because typically 50% of the course were pre-service science teachers of one type or another, and it was not only a requirement for graduation but preparation for the Ed TPA. Typical class size at that time was about 40 students. And what I did through an iterative design method was to switch the course from astronomy to active learning without computation and then add computation as active learning to this. So the revised course has the same content as the original astronomy course. Active learning replaced about 1/2 or even maybe closer to 2/3 of the original lecture. The computational exercises were introduced, in some cases replacing the active learning tasks, and in other cases supplementing them. So these were done, both computation and non-computation were done with a large amount of collaborative work, of group work in the class. So the active learning that I'm talking about are teaching methods which actually involve students during the class with the material. They are doing various activities in the class relating to the concepts. The students in doing this have to reflect on the concepts and think about them. Oh, how do I do this? How do I solve the problem with this? And one of the things is that active learning generally involves a large amount of student interaction, so it becomes much more interactive this way. So it leads to better comprehension and better retention of knowledge. Now, the computation that I'm talking about can be taught as active learning, which is what I did. It's teaching methods where students are doing some form of programming as active learning. They are solving problems using various programming methods, and this reinforces the material through student production of concept-based results. Another advantage of this is because 50% of the class were pre-service science teachers, and this gave me an opportunity to essentially give them an apprenticeship of observation, which is that you teach the way you've taught. I was able to demonstrate research-based instructional strategies to them, things like active learning, computation, group work, and how that sort of interaction works before they went out into the field to teach. Now, the original active non-computational tools that I had, there were some paper tools, things like lecture tutorials, and think, pair, share activities. Think, pair, share is the astronomy name for peer instruction. There were also experimental labs which were introduced essentially during the class time, during the lecture time, planetarium shows, and observational projects. Now, the computational tools that are available in general for doing this are spreadsheets, and spreadsheets will also generate graphs. Programming languages and packages like Mathematica or MATLAB. In doing this, I chose spreadsheets and doing graphical work because, as I said, 50% of the class were history, English, fine arts majors, and they didn't have a lot of programming experience. Spreadsheets are widely available, and they are also, spreadsheet programming is also easy to teach. Now, I had to do all of the computational exercises myself. There were no pre-written computational exercises, and I created a group based on light and electromagnetic radiation and instruments, another group based on the solar system, planetary characteristics, things like that, Kepler's law, and another group based on stars, Hertzsprung-Russell diagram, mass-luminosity relationship, those sorts of things, and a group of activities based on cosmology, like Hubble's law. So, examples of some of this stuff. These are non-computational ones to begin with. I would give students, a group of students, celestial spheres. And manipulating the celestial spheres and looking at it and discussing among themselves, they would come up with answers to questions about where you could observe certain things and why certain astronomical phenomena occurred when they did and the way they were. As an honors project, one of my students had come up with a lens lab where students would manipulate lenses to form images, just single lens at first, and then actually put a simple telescope on the optical rail. We also did, and this is our planetarium at Illinois State University, we also did planetarium shows where the students would watch and then they would discuss what they saw in the show in groups and answer questions and see if they could extend the material further. Computational, examples of the computational activities. This one is a graphing example where I gave them a group of galaxies and asked them to plot the recessional velocity versus the distance, find the trend line, and, find the trend line, and that was Hubble's constant, which for this group of galaxies was 57. I also asked them to graph the recessional velocity versus the redshift to show what the redshift was used for and what the relationship between the two was. This is a more computational activity that they did where they were putting formula on the spreadsheet in order to calculate the mass, not the mass of the star. They would input the mass of the star and it would calculate roughly what the luminosity of the star was in solar units or the lifetime of the star in years. In doing these, I used Excel spreadsheets, but Igor or Kaleidograph would work just as well. And students were given a template. They would bring their laptops to class, and students were given a template and a series of questions or tasks to accomplish, and then they would work together to find the solutions to these, do the graphs, make a program that would calculate something. One of the things that I implemented was rather than have them program with just symbols or cell designations like A2, I had them actually name the cells so that when they were doing their formulas, they were actually writing out the formula in words, which made the formula a little clearer as to what it was doing for them. In assessing the success of the computational exercises, I had both qualitative and quantitative assessments. For the quantitative assessments, I did pre-tests and post-tests with the test of astronomy standards and the lunar phases concept inventory. The test of astronomy standards is primarily to assess misconceptions that students may have, and the lunar phases concept inventory surveys student mental models of lunar phases, what causes lunar phases, and what the sequence is. All right, lots of numbers here. With the test of astronomy standards, for each of the semesters that I was doing computation, there was a statistically significant increase pre-post in correctness. The 2 control semesters, the first control semester was active learning without computation. The second control semester was straight lecture. With the LPCI, not all the computational semesters had a statistically significant increase in correctness, which I might expect because it's about generating mental models. However, overall, there was about a 10% statistically significant increase. The big result here, and this can be taken one of 2 ways, is that for the active learning semesters versus the computational semesters, for both the TOAST and the LPCI, there was no statistically significant difference between the 2, between the pre-post correctness changes. And I'm taking the optimistic view of this. One of the view is, well, gee, we didn't make any improvement here. The other is, that computation is effective as other forms of active learning in teaching astronomy. So, I also did a 17-question free response survey. 77% of the students thought that the computational activities actually aided their understanding of the concepts. 85% said that they thought they could use the spreadsheet skills elsewhere, both in other classwork and outside of classwork. The last 2 are essentially that the students enjoyed the group work and approved of the computational exercises. So, in concluding, I was able to do this iterative design method to switch a lecture-based course to an active learning course, and then using computation as active learning, which brought a lot more involvement, made the course a lot more interactive between both the students and the instructor. There were gains, significant gains in conceptual understanding, which shows that computational curriculums compare favorably with other forms of active learning, and the students enjoyed it. So, thank you. I will attempt to answer, or perhaps dodge, any questions that you have.
If anyone has any questions, please raise your hand. I'll come around with a microphone. While I'm doing that, and if you will start to transition to the next talk. Keith, you had your hand.
Yeah, so this is really interesting. I was wondering if you had tried at any point, you listed a large range of possible tools that you could have used, and you went with the spreadsheet, which I think is probably a very sensible choice. Did you consider having students maybe that came in, like maybe you've got a computer science student in the class who knows Python super well. Did you consider writing your assignments in a way, or would you consider writing your assignments in a way that for more advanced students, they could use the tools that they would prefer to use to accomplish the same task? And maybe the task is, get me a graph of velocity versus distance or whatever, recessional versus distance. But you could use whatever tool you want, and then you have your template set up for the students that are like, I don't know how to use a spreadsheet, because we'll always have those students. Does that make sense as a question?
It does. For more advanced courses, I would, and also more with STEM majors, I would certainly give other programming languages and other packages a try. For this one, I noticed a couple things. For this one, first of all, a lot of the students didn't have programming experience, but they did have access to spreadsheets, and so I wanted to keep this simple. In the beginning, the STEM majors were helping the non-STEM majors with issues of programming, but overall, by the end of the class, there was a free exchange that no one group was actually supporting another. Everyone had good ideas and were even pointing out errors of syntax to each other. And, no, you need to type an equal sign first, and things like that. So it worked out very well as far as the non-STEM majors picking up the programming.
Okay, I think we have just enough time for one question.
I have a very simple one, and I may have missed it. How many students did you have in this program?
I do not remember right now, but the typical class size was 40, and there were 8 7 semesters of data taken. So.
Your class size was about 40 on the average?
Typical class size was 40.
And 7 classes?
Semesters.
7 semesters of this.
Yeah.
Okay, so 7 times 40?
Yes.
Thank you so much.
All right. Thank you so much, Raymond. I will be moving along in just a few seconds here. Just a really quick housekeeping thing. Please, if you're exiting or switching to the other room for talks, please try to do that within that 3-minute transition period, just to not disturb the talks. All right, we're going to go ahead and get started with the next talk. This is going to be creating new educational materials for a non-calculus-based astrophysics course presented by Bragg.
All right, good morning. So I'm also talking about some computational activities that I implemented in an astronomy class. Instead of an intro class, this was an astrophysics class. So to give you a little more context for the class, it is the culminating course in our astronomy minor. And if you're wondering what this has to do with the planetarium, it's tangential, but when I was hired, our planetarium was under construction, and I was tasked to develop an astronomy minor because our planetarium donor wanted to have one of those at the college. And the challenge is that we don't have so many STEM students at our institution, and so I couldn't assume that students would have had much physics or calculus and so on in conjunction with or before any of these classes. So most of these classes are trying to be accessible to those non-STEM students. This becomes most challenging for that final course, Stellar and Galactic Astrophysics, for reasons that we'll see. Just to give you a sense of who is taking this minor, we've had about 20 graduates with the minor in the time that it's existed. About 2/3 have been physics majors, but the rest have represented diverse fields, including music, graphic design, psychology, history, and so on. So we get a range of students. And 2 of those courses, which I'm not going to be talking about, Life in the Universe and Big Bang and Beyond, also attract a number of students who are not minors, who just want it for gen ed or out of interest in the topics. As the name suggests, Stellar and Galactic Astrophysics has a heavy emphasis on stars. We certainly cover these topics in intro astronomy, but here we go deeper with more math, but not calculus, because I can't require that, or else I would have no students in the class beyond the physics majors. It would basically rule out that 1/3 of the minors who are not in STEM fields. So we certainly talk about stellar spectra, why they look the way they do, but with more math. We talk about stellar energy generation. We talk about stellar structures, why stars don't explode, why they generate energy at the rate they do, and so on. And then some additional topics that I'm not as focused on for the purpose of this project, like stellar evolution, the interstellar medium, mapping the Milky Way, and so on. So one thing that's been very challenging with this course is trying to find appropriate course materials. So some classes, I feel like I've hit on the perfect course material almost right away, and the book has worked well, and the class has gone smoothly. But with astrophysics, it's been a struggle because the materials that are out there, they seem to fall into 2 extremes. So there are the introductory books like OpenStax Astronomy, a great example of that. So that's fine for the intro course, but really not appropriate for a more math-intensive astrophysics class. But there's sort of a big step from those books up to things that look like this. And I think if you shook these books, differential equations would probably fall out onto the floor because there are so many with very little explanation in between them. Now, the book on the left is actually the one that I used as a student. And at the time, I had differential equations and was taking Calc 3. And even I found that a little bit daunting. The students in my minor are really not prepared to deal with something like that. So the problem is there's sort of this gap where you've got the introductory materials on the one hand and then these very advanced materials on the other hand. but I guess the assumption is that people in the middle are not taking astronomy because there don't seem to be books like that. So the way I've worked around this, I have used some of those differential equation heavy books, but as free ebooks from our campus library so that at least students weren't paying any money to be overloaded with these things that they don't understand. And I just would try to have them kind of read around the equations and hope they didn't get too intimidated. I delivered much content by lecture. Here are some of my lecture notes. And eventually I started trying to introduce a Python-based stellar model, and I had very mixed success with that. With the students, particularly with the non-STEM majors, it was a bit of a challenge. So for my sabbatical last fall, I proposed to create some new materials for this class. So both a course book, sometimes I refer to this as a short textbook, depending on who I'm talking to, but this is addressing those main topics about stars that I highlighted on the previous slide. So stellar atmospheres, why their spectra look the way they do, energy generation, and the interiors. And I wrote this to follow my classroom presentation at the level of math that I use, which is lots of algebra, geometry, trigonometry, but stopping short of actually using anything that might be considered by a student to be calculus. To along with this, I also created a series of scaffolded Jupyter notebooks using Python that align with the course book that do culminate in that stellar model code, with the idea being that students will be more prepared to see that and to understand it because they have worked through these earlier ideas in both astrophysics and in programming. So my approach to these notebooks was pretty deliberate because I didn't want to expect that these students had any programming experience, and my goal was really not to teach them how to program, right? There are entire courses that do that, and so trying to do that in the context of also teaching astrophysics would be a little bit too much to try to do in one semester. So to facilitate this for students, I tried to be very consistent about how I named things across notebooks. So if we had the speed of light called by one name the first time they encountered it, I tried to keep that consistent throughout every subsequent notebook so that they could recognize things and understand them. Whenever a graph was produced by the code or a number was calculated, I made sure that there were good axis labels and titles. These things we're always trying to beat into our students that need to be there. I scaffolded these notebooks so that the early notebooks used very simple programming ideas and things gradually built up so that generally they would only be seeing maybe one new programming idea per notebook, and so that there wasn't so much to try to take in. Needless to say, these things were also heavily commented so that anything that might be new to a student in the code, I tried to put a comment in there so that they could see what it was doing, even if it was something very, very simple, if it was something they wouldn't have seen before. And I avoided using black box functions. Python has lots of functions that you can use in all these libraries, and they're great. However, they could be very difficult to explain to students, and so I tried to avoid that as much as I could. And I tried to keep the focus on the astrophysics topics, not on trying to teach programming, because again, that was a side goal, I suppose, if students could learn to understand these programs and make small modifications, but that was not really the main purpose. So here's a list of all of the Jupyter notebooks that I created as part of the project. And so that very first one, calculate energy wavelength, all that one does is it allows the student to put into the code the wavelength of light in nanometers, and then it calculates the energy in electron volts. That's all it does. So something very simple that I would expect all of those students could do on their own, but this way they can see an example of a program that's not doing anything confusing or mysterious. And then we move on to more complicated function with the Planck function in that second notebook. And then in the third notebook, they see graphing for the first time and learn how that works. Then going into the level populations, well, actually, yeah, the spectral line calculator, they can give some bottom level in the hydrogen atom, and it will calculate the wavelengths of all the lines for electrons falling into that level. And part of why I created that notebook is that's a great place to put in a loop so that they can loop through the different upper levels and do these calculations. And again, it's a calculation they've kind of seen before, that energy wavelength conversion, but now in this loop and showing them more programming ideas. And then subroutines come into it very soon after that. Everything on the right is building up to the stellar model code, the final one of which is that iterative model at the bottom. So the things on the top half of the right-hand side there are just building up some of the different ideas like hydrostatic equilibrium and energy transport and letting them work with those a little bit until we finally get to those stellar models. Starting with the model I named the stupid model because it is quite stupid. It does a lot of horrible things, but it's also very easy to understand. And then the complexity goes up into these more elaborate models. So the final model there is an iterative model, so you actually get something out that isn't completely ridiculous. So the students guess at boundary conditions, central temperature and pressure, and a stellar size and luminosity, and then it works from the inside out and the outside in until the middle. And then the one piece that's new to students at this point is the subroutine that looks at the inevitable mismatch between what happens when the inside out and the outside in meet. And then it does a little bit of linear algebra to refine those guesses and runs until either it's reached the max number of iterations that the user specifies so that the program doesn't run forever, or when something unphysical happens like a negative temperature, or when you actually get an agreement within the tolerance that you can adjust in the program. So I used this for the first time last spring. I only had 2 students in astrophysics, and they were both STEM majors. So it was not a great test of how this would work for non-STEM majors, but it did go pretty smoothly. And one student even wrote on his course evaluation that he wished there were an Astrophysics 2 course. So that was great. So in the future, I would like to make the notebooks more freestanding by incorporating some of the text from that course book into the notebooks. It didn't even occur to me to do that at the time, but now looking back, I can see that that could be helpful. I did do separate homework assignments that used the notebooks in many cases, so I'd like to incorporate that more into the notebooks and the text itself and expand this to additional topics. Broader relevance, I think this sort of approach could be useful in other scenarios where you have kind of math-phobic students who can't handle calculus and complicated calculations, but yet this way they could engage with those. Thank you.
Thank you, Anne. We do have enough time for 1 or 2 questions if anyone has them. While that's happening, Jessica, if you could start to set up for your talk.
Thank you.
Thanks.
That was a great talk. Question about units.
Yes.
How do students feel when you spit in nanometers and you get out electron volts?
Well, the STEM students are not too fazed by that, but in the programs where I put in the physical constants, I make sure that there's a comment that says what the units are for that physical constant, because of course you don't put that in the program because the computer wouldn't know what that meant, but I would always comment what the units were and have comments that were very clear about what units you needed to use for numbers that you might be changing.
Okay, thank you.
Didn't seem to be a problem.
Okay. We have to move on to the next talk, but I do want to point out, if you have questions that you don't have time to ask during this part of the program, please seek out the speakers throughout the rest of the conference. I know that they are all more than happy to talk to you about the projects they've been working on. So if you don't get a chance to ask your question during the talk, please ask them afterwards.
There we go.
Okay, we're all set. All right, so we're going to go ahead and get started now. This is going to be Astronomy Outreach Education, a unique experience for undergraduates by Jessica Rogers.
Yes, hello. So I'm going to be talking about a course that I designed at my university. And I wanted to start off with just a little bit of background as to why I decided to do this. So at my university, I wear two hats. I am the Planetarium director, and so my staff are just students. And over the 3 to 4 years that students spend with me, I have really loved seeing how much they grow as both public speakers, educators, and things like that. And I feel like it's an experience that a lot more students should have. Unfortunately, I don't have the budget to hire all of the students at the university. So yeah, that was one part of it. The second part, my second hat, is as an instructor. So I teach most of the astronomy classes for the physics and astronomy department. And the classes that we had at the time were not really centered around the planetarium. We visited the planetarium a few times this semester, but nothing was really focused on it. And so I wanted a class that, really utilized the planetarium for what it was. So I designed this course, Astronomy Outreach Education. I quickly realized that I was not going to have time to teach all of the students in the class how to run the planetarium and build their own shows. So instead, I decided to focus the class on teaching them skills for communicating science to the general public through the medium of the planetarium, but with the understanding that, what they're doing, what they're learning can be applied to lots of different situations. So this is kind of what I wanted them to get out of the class, my main goals. So I wanted them to be able to, have some backgrounds on, planetariums, history, how they work. But a lot of the focus was spent on, how to communicate science effectively, how to have, good interactive presentations and programs. I also wanted to touch on K through 12 standards, because if any of them do go the education route, they're going to see that. So I wanted them to get a little bit of background on it. And then, of course, taking all of these skills that they learned and using them to actually create presentations and shows. So for the course, this is a rough outline, very rough. But in general, I split the semester into 2 parts. The first half is spent focusing on those skills and concepts. And so we go over, different tips and tricks and skills. We have lots of group discussions on them. We do lots of in-class kind of demos and activities, and then they also have a weekly homework that helps them practice the skills we talked about that week as well. And then the first half of the semester ends with a mini, I can't even really call it a training in the planetarium, but it's basically, here's how you push buttons on the control panel, and here's how you fly around with an Xbox controller, so that they could feel like they were giving a show, but without having to code everything themselves. Okay, so the second half of the semester was spent on their final project. So their final project had 4 parts. 1, they needed to pick a topic and create a 10-minute planetarium show on that. Now, I did all of the coding for the show, but they had to tell me what they wanted to see on the dome. So they were responsible for, what was going to actually be seen. I'm the one that just, did the code. And they also had to have an interactive element to their planetarium show. Second, I wanted them to create a poster that was in line with the topic of their show. And this was one to give them experience in a different form of communication, but also because a lot of these students are going to be presenting like research posters. So I wanted to go ahead and get them some experience with that. Third, I wanted them to have some sort of hands-on activity or demo that went along with the topic. Again, giving them more experience in different ways of communicating, and getting them to start trying to think of, how you can do hands-on explanations rather than just verbally talking. And then lastly, they just did a write-up on kind of their experience, but also touching on things like how would you adapt this for different age groups, and then also, what standards they hit. So I have taught this course twice so far. These are the topics that my students picked. Some you would expect, exoplanets, aliens, things like that. But we also had some really fun ones that I didn't expect, like formation of the solar system. I was really excited for that one. But what I really want to show you are a couple of the examples. So first one I'm going to show you, and the formatting got messed up, ignore that. This project was around life in the solar system and the universe. So the Planetarium show, we visited a couple of places in the solar system that we think we might find life. Their poster, which you're seeing here, is talking about how we've tried to communicate with any life that might be out there and what we're doing to try and find it. And then my absolute favorite was the hands-on activity they came up with. They decided to do an activity to demonstrate how difficult it is to communicate with something else that doesn't share your language. And so they did this with the form of a slinky, thinking about, light. And so you had two groups. One group was given a kind of cards with a slinky language. So different ways to move the slinky to have the different waves and things move back and forth. And then the other group was tasked with trying to figure out what they were saying. It was so cool and so clever, and I love it. And then the second one I wanted to show was, topic was exoplanets. So the Planetarium show went over the two main methods that we use to find exoplanets, so radial velocity and transit, as well as visiting a couple of interesting exoplanets. Their poster, which is what you're seeing here, talked about other methods for finding exoplanets. And then their activity was another one I really liked, and went more of the STEAM route. So they did a little bit of background on kind of different properties of planets, or of the exoplanets that we can figure out. And then they gave properties of an exoplanet, and it was your job to draw what you think the exoplanet would look like based off of the properties that they gave you. So yeah, those are just a couple of the examples. As I said, I've taught this twice so far. I've had a total of 11 students come through, and it has gone amazing. The students have really embraced the concept of the class. They seem to fully get behind it, understand the importance of it, and have a lot of fun with it. And this is really small, and I'm sorry. It's just a couple of the feedback from my students. This is also in the paper as well, if you can't read it. But lots of positive feedback, which has been fantastic. Just wanted to end with, my kind of final thoughts here. First is, I have no professional background, no formal education in teaching or pedagogy or anything like that. So a lot of this course was just based off of my own experiences or the own research that I did for myself. So I know that there are lots of ways to improve it, but I have been really, really happy with how it's gone so far. And I will say, I feel like I've been a little lucky to have two really good engaged groups that have come through. But I've also found lots of other benefits for it. I've gotten so good at coding shows now. And I have several times throughout the two semesters taken little bits that I have learned and immediately put them into our shows, into our public shows, because they were just so cool. And now I also have a nice little repository of shows and posters and activities that I can pull from to use in the Planetarium for other things. Now, as I mentioned, only have run this twice. I know that there's still a lot to improve on. One of the things that I have been debating over is that hands-on activity component, because for most students, there's a lot that's already been done, and I don't really want them to have to reinvent the wheel. So that's one of the components that I'm thinking about switching up maybe. But overall, like it's been great. Yeah, that's it. If you are interested in having some actual like course material or you want to know more about it, talk to me, send me an email. That's it.
Anybody have any questions for Jessica? Yes, right over there.
I actually like that you did the interactive portion. And I think you can still keep it because they can still use, just to find that ideal interactive. It's getting harder and harder because there's so many variations of the same thing.
Yes.
So having them, culminate and come out with that good activity that you can recycle and use and maybe have them even modify it might be a great way to still have them kind of invent but not invent the wheel. So I loved it. Thank you.
Yeah, thanks.
Oh, Jeannie has one. I'll come back.
I'm wondering what you did about the orientation for the interactive activity. There's so many age levels and developmental levels, and did you specify that you wanted them to tell you, was this for middle school, was this for first grade, second grade? What did you do?
Yes, yeah. So when they, in their project, they had to pick what age group they were gearing towards. But then in their final write-up, they also had to talk about how it could be adapted for other age groups as well.
How supportive was your administration? I assume was this a gen ed course?
Yes, and they have been very supportive. I'll admit there was also a slightly ulterior motive of being able to teach a class in the planetarium to get time in the planetarium counted as my teaching credit for the semester. But they were very supportive of it and have been really helping to push students to take it since, it's still a new course.
You're lucky. That's great. That's great.
Any other questions for Jessica? Oh, right here.
You talked a little bit about how you ended up having to learn a lot about coding for this because you did this class. What was that like? Because I'm not doing a course, but doing something along similar lines, or at least I plan to, in the spring semester. So I was wondering how that went for you.
Yeah, so, a lot of it was, it's Digistar coding since that's what we use. So it was a lot of learning how to effectively search the cloud and there was a lot of relying on scripts that were in the cloud and modifying them. And so it was just time that I spent really looking through examples that were there and figuring out how things worked. I don't know if that answers.
We still have a couple more minutes for some more questions for Jessica, but Cassie and Sara, if you wanted to start setting up your presentation, we'll go ahead and get that transfer going. Anne here has a question for you, Jessica, though.
Oh, thank you for your talk. I thought the course sounds really interesting. I'm just wondering how many credit hours and how much time it meets.
Yeah, so it was a 3-credit course, and we met for an hour and a half twice a week. And then again, we only regularly met for the first half of the semester. The second half, class time was spent working on the projects. And so for that second half of the semester, they had to regularly meet with me so that we could keep up on progress and I could give them feedback and things like that.
All right, wonderful. Thank you, Jessica. Okay, while they're getting that set up, we are a little bit ahead of schedule. We have about a minute before the next talk starts. So just once again, some quick housekeeping. If you do have questions that don't get answered during the talk, please feel free to seek all of the speakers out anywhere else in the conference. I'm sure they'd be more than happy to answer them for you. And also, once again, please try to use this 3-minute transition time to move in between the rooms so as not to disturb people's talks.
Sorry about the email links. They're blue and you can't read
Oh,
them.
they are blue. Yes.
They weren't. All right, so you want me to do an introduction, or do you want to introduce me? You don't have me in a slide, right?
No, you don't have your own picture.
Okay. So then I would.
You put yours and yours, right?
No.
Okay, we are just right about on time here. So our next talk is going to be If You Give an Undergrad a Planetarium, Student-Developed Planetarium Programming by Cassie, Ishaug, and Sara Schultz.
Thank you, Wayne. All right, good morning, everybody. Thank you for joining us. I am not going to do much talking. I'm going to be handing this over to Cassie soon, but I am the director of the Planetarium at Minnesota State University Moorhead, and very much like Jessica, I am the only person who gets any kind of a salary, and I have students who work with me. And they often come and do a lot of interesting things, and so I am here to support Cassie as she talks about the projects that she has worked on.
Hello, I'm Cassie. I am one of Sarah's student workers, and yeah, you're about to learn about me. I'm Cassie Ishaug. I am a senior at MSUM. We're right across the river from Fargo, North Dakota, if you know where that is. There's a whole movie about it. I'm a double major in Spanish and teaching English as a second language. Has nothing to do with astronomy or physics, but somehow I've landed here. So here we are. I know, kind of exciting. But I'm in my 4th year at MSUM, and I've been working at the Planetarium for 4 years. It all started when I just walked into a meeting, told Sara my major, and she went, hired. That is literally how it went.
I remember that.
You remember that? Yeah, that's literally how it went. It was super weird. But somehow I'm still here. But this is me as a Pokemon card, because we like to joke around and say that Sara collects majors like Pokemon cards, because there are so many different majors working at the Planetarium. There's no consistency. But I made Pokemon cards out of us, so we're collectible now. One of the things that's really cool about the Planetarium, since it's mostly student workers that are there, Sara's the only full-time staff member. We have a lot of student-developed programs. This is a list of the majority of the ones that are shown fairly regularly. The ones that are bolded are the ones that I've had a major part in, and the 2 pictures that are visible are of skies over Hogwarts. And this picture was actually from like 2 weekends ago of some of the staff members that we dress up in costumes and do like a whole character thing. It's super fun. The kids come in their Halloween costumes, dressed as Harry Potter. It's amazing. But the 2 that I'll really be talking about today are Stars of the Vikings, which was an adapted show from Brian Kaler. Okay, Brian Kaler. And then Orchestra in the Stars, which I actually completely wrote from scratch with the help of one of my friends and a former Planetarium worker named Alexis Novak. She graduated last semester. The general process that I follow for writing shows is along these lines. I go idea, vision, research, create, promote, and perform. This is just kind of the general process. We'll go more in depth on these. The idea or the starting point, these are 2 pictures that I chose to represent the 2 shows that we're talking about. Orchestra in the Stars is that one over there. It's the Thinking Man statue, because we decided to have that statue recreated as a constellation in the circumpolar sky. One of our student workers, Abby Moen, is a wonderful artist, and she drew the Thinking Man as Ursa Major. Yeah. And then we have Yggdrasil, or the World Tree, for Stars of the Vikings, because a lot of the Norse constellations have to do with the World Tree. And that's how a lot of those kind of legends correspond to the sky. Next, you want to form a plan or get like a vision. For me, it was finding the people that I wanted to do this with, because I knew I didn't want to work alone. I hate working alone. I can't keep myself on track very well. So for the Vikings one, I got help from one of our other friends, MJ West, and I think some other people, but I honestly can't remember. It was a group effort. I was constantly pulling people. I was like, I need help. But for the Stars of the Vikings, as you can see, it's literally, that is the plan we drew out on the whiteboard in the planetarium. Yeah, the top part is the graph from the school shows because we didn't want to erase it and have to redraw it. So we just left it there. We're very organized. But I got my group of people together that I wanted to work with. And we formed a plan. And that was the plan for the Viking show, or for the orchestra show. And then you want to also think about the people in the community that you're serving. And that's why we have the little Moorhead logo down here. Because for the Viking show, we knew that the community we were serving, we wanted that show to serve that community. And there was a lot of bits in that show that we could alter to fit the community. There is a Viking ship in Moorhead called the Jomkomst. It's a Viking recreation. It's a ship that was recreated. And the man who built it was a counselor at a middle school. And he had such a big impact on the town that the building that the ship is in is the city's logo. And they've named an elementary school after him, after he passed. So I knew that that was a big part of Moorhead. I grew up in Moorhead, so I kind of knew the place, but I knew that I wanted to tie that in. So I knew that we needed to serve the community, and I wanted to bring it in. I knew that we wanted to have kind of an interactive format and be talking with the people and not just have us standing up there and talking straight at them the whole time, like robots. And I wanted them to walk away amazed. So that's kind of the takeaway. All right. Next, you're researching, writing, or adapting the show. This is a picture of me writing the script for Orchestra on the Stars. I spend the majority of my week in the planetarium. That's where I live. Yeah, it's pretty self-explanatory. Collect as much as you can, write however you write best. I collect a whole bunch of links, and my bookmarks on my computer are so messy because I just have so many bookmarks. But yeah, I was writing with Alexis, and she said, "You look so funny right now because you're hunched over the ticket booth writing." I was like, I bet I do. But yeah, so this is me writing the script. And the script for that show took us a semester and a half to write, but we made it through. And then we performed it, which we'll see in a couple slides. After you've gotten it written, you want to put all of your pieces together. And for us, it was getting the artwork from our friend Abby and then putting it with all of the research and writing. So we used Stellarium and WorldViewer. So OpenSpace, Stellarium, all compiled in WorldViewer. So we put our artwork, our custom artwork, into Stellarium. So that's what you're seeing there. This is the Viking show, and that's the Orchestra on the Stars, both in the winter sky, which is kind of fun. I didn't realize that until yesterday, that they were both pictures of the winter sky. But we have a picture of the actual Jomkomst sailing. So the original voyage of the Jomkomst was from Duluth, and then after Robert Asp passed away, his kids took it from New York to Norway in his honor, which is pretty cool. But there was a Viking ship Constellation in the stars, and so I was like, we're gonna make it the Jomkomst. And then there was also a bunch of lore that we got to share about the different views of how the indigenous people in Scandinavia saw the Northern Lights. So we got to put a video of the Northern Lights on the ceiling while talking about the different stories. And it just so happened that last spring, there was a huge solar storm. And so one of our professors went out with the 360 fisheye camera and took a video. So we actually got to put in a video that was taken from the Regional Science Center out at Buffalo River State Park by our university. So that was another way that we were able to tie it into our area. You also want to make sure you're promoting your show. Get butts in seats. I think that's a funny way to say it. I love Canva. I'm not paid by Canva. I wish I was, because I promote Canva so much, because I love Canva. But I made these posts for Canva, or with Canva, to promote the shows. These are Instagram posts and then just the poster that we hung all around campus and all around downtown Fargo. But yeah, making them flash to get people there. And then finally, you're performing your show. This is the day your show gets to live and thrive. But this is a picture of me and Alexis up at the front of the dome. She drove on the computer and I performed and did all the speaking. And then the whole point of this show was to have the live orchestra in the front of the dome. It all started, the whole idea with this was Sara in a meeting one day said, we should do something with the orchestra again. And I said, okay. So that's how that all started. It went quite well. We have the full video on our Google Drive, so if anyone wants to see it, you'll find us later. And that is all. Thank you very much.
Thank you very much. Anyone have any questions? Yeah, come on over.
Hi. That was great fun. You mentioned that you put a lot of work into the script, and I'm wondering how that worked. Do you like show it to other people or perform it to each other, and did people get to react? Because I've often had that sort of problem, like a script, you don't know what the problems are until other people have heard it and reacted to it.
Mm-hmm. So we have quite a few people that work at the Planetarium for student workers. So one thing that I do is I will be like, hey, you want to sit down and just read the script with me? And we'll all sit down in a room and we'll just read the script and alter things. Even if a show has been done multiple times, a lot of times we'll go back and look over the script because there's usually something that can be fixed and altered to make it work better. But just rereading with other eyes can always help.
You said that your Spanish is part of your background. Were you able to incorporate your Spanish-speaking skills into your work in the planetarium at all?
Yes. I was originally hired to do Spanish translations of shows, but I got bored with that really quick. So instead, I decided to learn how to do everything else. So I know how to run literally every piece of technology in that dome, but I've only done one full Spanish translation, and it was in my first semester.
That's awesome. Thanks.
She is going to be working on a Chilean program for this fall. Well, yes, I'm supposed to present it in November, so we're going to be doing that at some point. But as much as I've tried to push Cassie to do more Spanish stuff, she likes to do other things as well. So she does a great job. I'm very proud.
Hi, Cassie. That was really amazing. So I was just kind of blown away in little tiny pieces talking about all the ways that you were able to really instill local and kind of historical, personalized elements into this Norse show. Did you get a good payoff with your audience, kind of being able to point out, that's the ship, oh my gosh, I remember when this is in the news? Like, did you get people kind of getting the light bulb over their head moment at all?
I honestly don't remember. I think I was so stressed because I had put so much work in. I remember for the orchestra show, it was completely sold out. And then for the Norse one, it was almost sold out. I think one day it was completely sold out. But I remember being so stressed. I was like, I need this to go well. So I think there was it was for the Scandinavian Festival in the Fargo-Moorhead area. So there was a lot of people that were very new the area. So I think they all immediately were like, oh, I know that. They recognized it. So I think that was the case. And I just didn't see it because I was stressed, but yeah.
That's valid. Well, it sounds like it was beautifully personalized, and I'm getting a lot of nods from Sara, so I'm sure it went fantastic. So yeah, that's really an amazing labor of love there. So congratulations on that.
Thank you.
All right. Once again, thank you very much, Cassie and Sara.
So I'm just going to stay up here for like the rest of the day. So. Okay, perfect.
It's got like 30 seconds.
Okay, perfect. I'll grab a drink of water.
All right, so we're going to go ahead and get started with the next talk. This one is going to be the GLPA Visiting Planetarian program by the self-proclaimed queen of the universe, Sara Schultz.
You can feel free to use that title for me anytime. Well, thank you for all being here. This is putting on a little bit of a different hat for a moment, and then we'll get right back into my students again. But I am the newly elected Inclusion and Outreach Officer, and thank you. I had some ideas about how we could potentially work on outreach for the planetarium community and GLPA specifically. And so I wanted to talk about this. It's not a finally fully fleshed out idea. So this is going to be a lot more interactive. I'm hoping to get a lot of feedback from all of you. So I'm just going to kind of tell you about the thoughts that I've had, and I want to get some feedback and think about what we are really looking for and what we can do with this. So to give you some idea, when I took over the Inclusion and Outreach Officer position, I had big shoes to fill. Thank you, Keith. You've done an amazing job. And it was very intimidating. But I was kind of thinking a lot about outreach and how we can bring in a more diverse population into our community and how we can get more voices. And me being who I am, I immediately thought about students and thinking about how to reach a younger group that may need just that little bit of a push to realize that this can actually be a career. I know for a lot of us, we almost all have different ways that we got into the planetarium. And so there's no one real defined career path. And I think the sooner that we can show that to people, the better, so that we can get more people involved. And so I kind of had this idea, and it wasn't really even I didn't even start this. My students did. Actually, specifically, Emily, who's up here and will be talking in a moment, and MJ were at Stars for All last year. And I was not, because my husband broke his hip the night before. So I stayed home, and my students did a lovely job, and you all welcomed them very nicely, and I really appreciate that. But they connected with a student, Ivy, from Kentucky. And they got to talking and decided, hey, it would be really cool to be able to come and visit your location and learn about the things that you're doing with your planetarium, with your students, with your community, etc. And so we decided that we would like to host her for a week. And so we ended up coordinating that, and we hosted, so we took care of the, I'm getting a little bit ahead of myself, but I'm about to do the next slide. The point is that we want to reach more people at an earlier stage and reach a more diverse population, get more voices in the planetarium. And the way to do that is to start younger. So now what we did is the students connected. I connected with Ivy's mentor, and we talked about, is there any way to get some funding for travel? She flew to see us, and she was able to ask for some money from her department. She stayed with Emily and MJ, and so that handled the accommodations, and we handled food and everything for her while she was visiting. And so we hosted her for about a week, maybe a little bit more, a couple days extra maybe. And we tried to plan it around convenient times for her and for us. So it was a convenient time for her that there was some, like a fall break or something, but it also happened to coincide with our homecoming week. And so certainly we were going to be having lots of things to do during homecoming, and we were doing our Harry Potter show. So we had an opportunity to get her involved and be one of our characters during that show. So we had a lot of fun, and we would love to do it again. And I think that there are other people who could benefit from something like this as well. Because I know for ourselves, the reason that we're here is so we can learn from each other. And ideally, we could all travel to each other's domes and learn about the things that you do there. Well, that's not very feasible, but we can try to start with students and send them out and just explore this kind of career path. So Ivy had a blast. My students had a blast. They can attest to that. You can ask Watts later. Oh, Cassie, you were there too. So we had a good time. But it really helped Ivy to realize that not all planetariums are the same. Hers runs very differently than ours does, and that there's a lot of different things you can do with it. And so it just kind of helped kind of cement that in her mind as something that she's really interested in going further with. So I think it was a really good impact, and I know for my students as well, it was nice to see what other people do. So the question is, how would we implement this? And this is where I'm needing some help and some feedback as well. The idea that I came up with was to do something kind of based on IPS's a week in wherever, fill in the blank, where we have some support from GLPA to help kind of maybe a travel stipend or something like that. Not a lot, but something to help kind of foster this relationship. We'd obviously have to have volunteer hosts and volunteer people who would like to travel. So there's that. But so my idea is to hopefully kind of base it off of the IPS's program and see if we could do something similar. So this was what Ivy said about her experience and her desire for this. So I'll just go ahead and read it. I think that's my primary reason for wanting a program like this, so I can learn more about myself and strengthen my skills by learning from and observing others in different environments. So not only did she learn about us, but she learned a lot about herself as well and what she's looking for in a planetarium career. So I think that that's really important for us. I mean, all of us, I think we all could have benefited from something like that early on, and to say, hey, is this what you want to do? You want to go this direction? You want to go this direction? What are you looking for? And where do you fit in? And of course, just for fun, they had a lot of fun. And so there's Cassie in the middle there on the far one, and Watts, I don't think you're in there, but MJ's in there. You might recognize her. But they had a lot of fun, and it was really fun to have someone come and visit and be able to kind of show off ourselves as well, which was a good time too. So kind of thinking about the specifics, when I talked with Ivy, I think her airfare was somewhere between $300 and $400 or something. And so I guess that's my idea of where we would kind of start, is doing some sort of like a travel stipend like they do for IPS. Of course, this would require having people who are willing to host and to potentially carry that financial burden of room and food, right? We thought that approximately a week was pretty good, because, you got the traveling and stuff, and you want to be able to experience a nice spectrum of things that happen in a planetarium. She got to come and see some of my school shows. We got to do our public shows. We got to do some other things like for the students and stuff. So it was a nice opportunity to get a good view of the different types of things that we do. Certainly, I think that this kind of an opportunity would be priceless, right? Those commercials with the credit card things or whatever it is, right? $300 to go to visit another planetarium, a planetarian career, priceless, right? And we all know it because we love our planetarium people. And so we want to share that with others as well. So let's talk about it. This is the time when you're going to have to get up and run around, hopefully, because I want people to have something to say. Mary has something to say. But essentially what I want to know is, do you see benefit in this? Do you think this is something that we should pursue? What concerns do you have? Do you see any drawbacks or problems with doing something like this? And you can see the rest of the questions, and I'm going to let Mary talk.
First of all, thank you for this idea. This is very exciting. I love this idea so much. And we should talk more because we're starting a new subcommittee with the IPS EDI committee that's a mentorship and belonging subcommittee. So we want to
Perfect.
get that going
Yes.
as well.
Mhm.
So that definitely fits in. But my question is, are you filled with as much existential anxiety as I am of I really want to attract younger, more diverse folks into this field, but I'm so terrified that there will be no place for them since there's just like so little space in the planetarium community. I'm like worried about encouraging them and then they can't find a job. So I'm curious how you feel about that.
I have not thought about that. Thank you for crushing my dreams. No, I'm kidding. I'm kidding. No, I guess I haven't thought about it, but I think that even if it doesn't end up with them under a dome, it's still very valuable. And that doesn't mean that they will never end up under a dome. So this could take them in a different direction that's not specifically planetarium, science education, science communications, all of these things. And all of it is valuable. And it's always good to have those voices. So I guess I don't have any existential dread about that. We could talk later about the other ones. But no, I think it's better to have them come in and then show them other options as well than just leave them out.
Kind of following up from Mary's point, as a very anxious person myself, I think like many of us, at one point I had to move in my career to take a new job, and
Yep.
I think one of the really valuable things this creates is it gives hopefully that actual sense and experience that it's okay to go somewhere else than where you grew up, and that way you don't have to be like the crew on a bird of prey and kill your mentor to take over the planetarium.
Woo, that went a direction.
Well, I was playing the murder game last night.
Yeah, that's right.
But yeah, no, I think this is really incredible because I think something like this. I mean, I had to move in my early 20s. It was a very anxiety-inducing experience. It was a big
Yes.
change, and having had the experience of doing a week at another planetarium, I think really it will hopefully make it feel possible to people. And because I think being open to moving anywhere in the country is the key to your
Right.
future in this profession.
It's true, yeah. And I think that also helps to solidify the fact that I talk about this all the time, how supportive this community is and how much we look out for each other and support each other. It's amazing. And I don't know that you can find that in very many other places. And granted, I don't really tend to travel to other people's conferences, but I'm going to brag about us, whatever. But yeah, I think it gives a really valuable perspective.
I have a little piece of nitty gritty.
All right.
It seems like in our community there are different slow times depending on whether you're a university or a museum.
Yep.
So I think it would be really clever if in the initial ask you specified the week.
Sure.
So that people understand what I'm signing up for. Does this work or not? And then you don't have two people that you've matched, but the time that works for them
Sure.
isn't the same.
That's a very good point, and actually I thought about that too. And I think that's a very good thing to keep in mind. However, I'm ever hopeful that we'll have a lot of potential hosts. And so the person who is applying can say, I would really like to go to a planetarium that's in a museum. I would really like to go to a K-12 planetarium that's, in a school. I would really like to go to something, a standalone planetarium, whatever. And so being able to connect the correct person with the correct location. So hopefully that wouldn't be a problem. But of course, it's always, people, things, figuring all that stuff out. But yes, of course, trying to connect people. And if the person, maybe when we have the application, the person says, this is the time that can work for me. Excuse me. And so then we look for a host that can handle that time frame. Good point. Thank you, Jean.
On the theme of adding to your anxiety, and this isn't something you have to answer, but just something to think about.
Sure.
Risk management and liability.
Yes.
Not sure where it lies, if GLPA gets part of that, if we're providing some funding, but just something to kind of check out with whoever the host institution is.
Of course.
All right, I know that there are more questions, but we are starting to run
Sorry, I did not want to do that, but thank you all.
We still have about 30 seconds.
30 seconds.
But, and Sarah, you are talking
this.
next as well. So.
Oh, that's true. So I can just,
So I
got this.
We have enough time. I know Madeline had her hand up, so we'll let Madeline ask a question, and then we'll move on to the next talk.
I will. For a brief second, I do have. Oh, that looks terrible. A feedback QR code, and I will be talking about it during the business meeting as well. And I will also have that QR code up there. So please give feedback, whether you think it's a good idea or a bad idea. Please give me some feedback so that we can plan. And we'll let Watts go ahead. Oh, sorry, Madeline, sorry.
No worries. I just wanted to say I love this idea because I know as someone who is newish to the field myself, there's a lot of times where I'm like, I have a vision for something and I have this feeling that it probably can be done, but sometimes you just don't know where to start unless you ask someone. And I know that like this summer, Waylena McCulley graciously drove up to my dome and helped me figure out a couple of things that turns out were actually really easy. And so I think this is a great idea to like foster things like that and make it easier to learn from each other.
Thank you.
All right. We're going to continue with the Dr. Sara Schultz hour here in the in this session. So this talk is going to be Connecting the Dots, a GUI for custom constellation artwork in OpenSpace with Emily Watson and Sara Schultz.
All right. Well, you already know who I am, unless you came in late, and I'm Sara Schultz. And this is my student, Emily, and I'm very proud of her, too. And I'm going to let her do most of the talking.
All right. Thank you, Sarah. Good morning, and I would like to thank you all so much for coming to listen to me today. My name is Emily Watson. I am a fourth-year physics and astronomy major at MSUM, and I also get the absolute pleasure of working at this planetarium. Now, I did promise Cassie that I would also put my Pokemon card in my intro slide, so we are in fact collectible, and I do have Sarah's trainer card as well, and her ability is collector. And this will fit in as I will be talking. I will be kind of expanding on what Cassie talked about today with show presentation, and I will specifically be getting into the portion of implementing the artwork for constellations into some of the shows we do. So to start, we work mostly in Stellarium and in OpenSpace, and specifically some of the main shows that we do in the planetarium involve taking our Western constellations and reimagining them, whether that has to do with taking other cultures, like Cassie talked about the Norse mythology show seen here, and sometimes we also do more fun shows, which we also saw in the last couple, like Hogwarts. And this one is one of our more fun shows that we do. We reimagined the stars as Hogwarts characters. You saw some of our acting from those. And those can be really fun for both our community members and for our staff. Going along the theme of collecting, we collect a lot of majors. Being at a university, we have a couple STEM majors. Otherwise, we have a lot of arts. We have a lot of communication. We have teaching English as a second language. Yay, Cassie. And we have all sorts of things. And we need those voices in everything we do at the planetarium to make our shows effective and fun for our audiences. But with that, there can be... Oh, can you go back, please? Sorry. Nope, you're good. Yeah, but with this, we have also found outside of these shows being really enlightening for our students to learn to create, it is also really good for our community. They can see themselves in these shows that we make, whether they be cultural or if it's just a story like Harry Potter that they really enjoyed as a kid and now they can connect astronomy to something that they knew when they were a kid. Now, Cassie did not have anyone to attest to the fact that her show went very, very well, but I got a lot of good reviews from her Norse mythology show, and people were telling me about going to the Yomkomst Center as a kid and then being able to see that in the constellations. So we do have that community aspect that has been really beneficial for connecting some underrepresented groups that we see in our community and getting them comfortable to come into the planetarium and learn about the stars, and hopefully that will bring them back to learn about more astronomy besides just the cultural constellations that they came to see. Now, up until this point, most of our stuff has been done in Stellarium, and we do this by going into the files on the back end and changing the custom constellations. We input artwork, and this can be tedious, but it's not impossible, and we have done this for many shows now. But with this being a university planetarium, I'm sorry, Sarah, we graduate every 4 years. And I'm sure any of you that work with undergrads may attest to this plight, that as soon as you get them trained in the way you want and they start to become comfortable in presenting and show creating, they graduate and they go out into the world and the cycle starts anew. So seeing this as now a senior and someone who has taken on more of a mentorship role in the planetarium, I wanted to see how I could help this next generation of at least our students at the planetarium be more confident as presenters and not let things like the tech side of putting in constellations in the sky stopping them from sharing a story that they want to get out into the community. Now, this led me to looking towards OpenSpace, which is the other software that I use. Yes. Yeah.
So I'm just going to step in real quick because in the spring last year, we hosted a workshop for world viewers with Illuminati, and we also had OpenSpace there, so it was kind of a combined workshop. And we talked with some of the developers about what might be useful for the greater community. And this kind of came out of a conversation with some of the developers and thinking about how we could work with them to provide some assets for the user community for OpenSpace.
Yes, thank you, Sarah. So with that jumping point, we then began over the summer to think about what we could do as college students to help the greater community of OpenSpace. And one of the things I went to immediately was custom constellations, because we use them so much in Stellarium. And over the past year or so, I've become a lot more comfortable driving in OpenSpace. And I've started really enjoying the functionality of being able to go from an Earth-based perspective, looking up at the stars, to just being able to lift off and go fly out into the solar system if a kid has a question about Jupiter or something. Whereas in Stellarium, I would have to switch softwares, which can just be clunky, and it helps the showmanship of the presentation I'm doing. So this led to talking to a lovely fellow, James Hedberg, at the CCNY Planetarium, who does have a current way to input custom constellations into OpenSpace. It involves editing the current constellations asset file and the custom constellation art CSV. I'm happy to point you to that if you would like after this presentation. And also talking with Micah Akanapura from OpenSpace, and then working very closely with a former student, Aries Qualley, who did a lot of computer science in her time at MSUM. We started developing an idea for a GUI, or a graphical user interface, that planetarians could use to not have to edit the back end of the code to run custom constellations. So my full goal with this project was to make it easy to use so that any major coming into the planetarium would be able to utilize this functionality and not have to be so bogged down by the idea of going into file paths and CSVs and what is an asset file, and making it as customizable as possible, which we'll get into here. So as much as I would love to walk through all the code that we did in Python for this, that would not make for a very good presentation. So here is a little outline of what our code currently does. So you start with a launch page, and then there are three options. You can either create a new custom constellation, you can edit an existing file, or you can load a set into an asset file to then go into OpenSpace. I will preface that this is very much a beta version of this. We are going to be working on it throughout the remainder of my school-ish at MSUM, and hopefully by the end of this we will have a distributable product. So for right now, what happens when you launch the program, you do currently need some sort of coding software like VS Code or Jupyter Notebooks to run this program. That's something I'm hoping to take out in future versions. If you then get this screen, you get create new, edit existing, or load set. If we hit create new, we can then edit and choose which constellations we would like in our custom set. Currently, this only involves using the 88 IAU constellations, and I will get into what functionality I would like to change about that in a bit. But for this example, I'm using Canis Major and Canis Minor. So once I have grabbed those, then up in the top left corner there, it says select an image for Canis Major. So I would then select one of my images I had previously downloaded, hit open, and it would repeat the cycle for all the constellations that I have selected. So this basically takes out the need to go into the CSV and manually change each cell. Once this is done, you can then save the CSV to where you would like. Otherwise, it automatically saves to a custom constellations file. And then you get a lovely little file is saved successfully, which is good, because if it does not, it will also let you know that, and then the process starts anew. But this was the main goal I was hoping for with the beginning of this code, is just that the file paths work correctly and that it's saved as it should. So now if you needed to edit anything in the code, you could go back and, no, you're good, that's correct. You could go back into the edit existing and redo the process you just did. After this, if you want to load your new custom constellation art into an asset file, you would then go back to the main screen, which it automatically takes you back to, load set, select the CSV that you just created, and then when you hit open, it automatically saves it to a custom constellation asset file. Yep. And one of my current favorite things about OpenSpace is this lovely drag and drop feature. So what you can do is once you have the asset file, you can just drag and drop it into a running profile of OpenSpace, and a new little drop-down will appear. So over on the left, there is now a drop-down that says Constellation Art Custom, and this has all the same toggle on and off constellation arts that the regular constellations drop-down has in OpenSpace, just with your custom artwork instead. And if we go one more forward, you can see an example of what this may look like. So this is Micah's lovely artwork, vaguely Canis Major and Canis Minor, but I believe the one on the right is his, or on the left, sorry, is his dog. So that's one thing you could do with this program. So a couple limitations currently is that there is no way to scale the artwork once you have put it in, and you do need to go back into the CSV to change the scale, retest it, see what works. So there are a few things I would like to modify, but that's also why I wanted to bring this before all of you lovely expert planetarians, is I would love some feedback about what actually is effective in what you need for show creation. So one thing I would eventually like to do is not be constrained to the IAU constellations and be able to select any star in the night sky to be the center of a constellation, just so that any culture or anything like Harry Potter could be in our night sky. And so then having a what is called an API, or an application program interface, which is kind of like a pseudo window of OpenSpace that could run in real time. And then you could use sliders. Ooh, those sliders did not like going to PowerPoint. Sorry about that. Those sliders could then scale the images in real time for every constellation that you have inputted into your program. Now, this would all be run through a web app, so you would not need something like a Python code to run. And this could be something either on like the OpenSpace website or something you could access and then run from there. So this is still very much in its beta versions, but I am hopeful, looking forward into what I can do to try to make show production and creation a little easier for the next generation of planetarians at the Planetarium.
And ideally, what will happen is that this, when we talked with Micah, if we can get this working well, it would become part of the OpenSpace package, and you would be able to go to like OpenSpace.custom or something, and you'd be able to do it right in there as part of their website. So that's the goal.
All right, and I believe
Wonderful.
that is all I have. I would just like to thank you one more time for being such a lovely group and being so welcoming to me and now Cassie these last 4 years. It is just a wonderful organization to be a part of, and thank you very much to Sara.
Okay. We have enough time for one or two questions for Emily and Sara, but while we're doing that, Katie, if you would get set up for your speech. Dan has a question. Great.
I just assigned someone on my team to make constellations in OpenSpace last Thursday. How could I get a beta of this from you to speed up his work?
I believe I have it on a flash drive with me. Otherwise, I can email it to you.
One suggestion, along with being able to make them bigger or smaller, rotating the image would be another access point that you would want to probably put in there for a show creation.
Yeah, no, yes, thank you.
Anyone else? Madeline, yes.
I was a little bit curious just how this worked, but you were selecting various of the different IAU constellations, but does that just like add like additional art that you could pull up for the constellations, or does it overwrite the usual art? I was wondering how that worked.
Yeah, no, that's a really good question that I thank you, I should have clarified. It adds additional art that you can pull up. So in the code, it's overwriting the CSV file to save as a new file. So then you have both, you can use the traditional IAU, and then there's a custom one that you could also pull up that as of right now just goes to the same location.
Excellent, thank you.
Sorry, Benjamin, but we are running into Katie's talk here. Once again, if you have other questions, please seek them out elsewhere in the conference. All right, so our final talk for this morning is going to be Katy Downing presenting Sky Safari, a new show for young children and their families.
Awesome. Thank you very much. My name is Katy Downing. I am the Planetarium and Programming Coordinator at Lake Erie Nature and Science Center. I'm going to be talking about something completely different. Most of my audience is 0 to 7 years old. So I do not have students. I have 4-year-olds. So we're doing total change of gears here. So our planetarium, we're a 30-foot dome. We are attached to a nature center, and we do wildlife rehabilitation, and we also do preschool. So that's where most of our audience really comes from. So post-COVID, this was our show schedule. We did shows 6 days a week. Twinkle Tots, Stellar Stars, Mini Missions, and Sky Tonight are all live shows where the topic changes every single week. So we do about 55 different live shows. And then the Children's Full Dome show during the school year is Little Star That Could. So we just show that every Tuesday and Thursday. Saturday, the Full Dome show is for adults, or really anyone who can sit still for a half hour and watch something a little more intense than Little Star That Could. So everything was going great. We were doing a mix of live shows. We were doing a mix of full dome shows. But then our digital projector died. He did a good run. Our Barco F-35 lasted 9.5 years. Which is absolutely incredible. So the day he died, November, I don't remember the date exactly, it was before Thanksgiving, but it was November of 2023. What did we do? So we, Google Slides to the rescue. We lost 1 day of programming after the projector stopped working. I mean, it was like lights on, nobody's home, not connecting at all. So you can tell from this picture, we still have an optical mechanical start ball. And we also have mounted in the back of our dome, a tiny little, like PowerPoint projector. So it was really Google Slides to the rescue. We converted all of our shows to Google Slides, and then we used our Spitz 512 to do the nighttime sky portion of our shows, and everything was great. But the problem was, how do we replace our 2 popular shows, Rusty Rocket and Little Star That Could? We could not show those. So enter a brand new show called Sky Safari. Why did we need to do a new show? Why couldn't we just keep on doing Twinkle Tots? We already do Twinkle Tots 4 days a week, and we would saturate our market. So we had to come up with something new. So Sky Safari is recommended for ages 2 to 7 or anyone who wants to have a story time under the stars. We focus on animals because we are a nature center, so we focus on the animals of the nighttime sky. And we find them in the sky, we put the lines up. We did this with so we were running Uniview up until last month. We were running Uniview, so we would run Uniview flat screen, and we would put the lines up there, and then we would have to navigate around to find it. And it worked. It worked. Was not ideal, but it worked. Then we would put the picture up there, and then we would hear this constellation story. Now, as most of you know, most mythology is not appropriate for 3 to 7-year-olds. So we completely reinvented mythology. So here's the thing. Constellations are an oral tradition, and I don't know if you know this, but you are allowed to make up your own. We always tell the kids, make up your own. So all of our mythology is based on children's literature. Have you seen a kids movie? So we base most of our stories on little kids stories, Disney movies. We have one constellation, the constellation of Lacerta the Lizard is brought to you by the movie Rango. Nobody notices, but it's great. So we just use our creative brains and come on. We work with small children. We are large children. So we consume children's media because it's better than a lot of the grown-up stuff out there. So we just have fun with it. So here is our Sky Safari rotation. We have 10 different shows. I think that's 10 different shows. And we do 3 animals. Now, my staff created this. So some of the themes are great. Some of the themes are totally out there. My personal favorite is the letter L. We have mythology, we have invertebrates, we have birds, and then we have the letter L. That's what happens when I leave my staff alone in the dome. So our show format is we find these in the sky, we tell their constellation stories, and then at the very end, we just fade down all the lights. We start the stars turning very slowly, and then we play some classical music, and we call it thinking music. And then we encourage the kids, it's my turn to stop talking, it's your turn to start talking. You talk to your friends and your grown-ups about what you see in the sky. And the kids, they're always shouting, they're like, I see a rainbow, I see a unicorn, I see a fire truck. Like, they see so many cool things. So we just have the sky slowly turning with some classical music in the background, and they're pointing and shouting out and using their own imaginations. So it's working really well. The kids love it, the grown-ups love it, and it's basically story time under the stars. So this is my plan for the last bit of my presentation. Anybody want to hear a story of one of those? Which one? The letter L? Oh, letter L has a great one. Okay, so lynx. Can you find lynx in the sky? It is Northern Hemisphere. I fully admit I rely on Uniview to tell me where it is. But lynx, who knows what lynx's mythology is? Our mythology is lynx's day off. See, lynx is a mama cat. She has babies, and she drops her babies off at kiddie school. So Mama Lynx is going to have the best day off. She hangs out with her friends in the forest. They play chase. They pounce on little chipmunks. They have a great morning. But what do moms love to do on their day off? Take a nap. So Mama Lynx decides she's going to take her nap. So first, she finds a pile of leaves. The leaves are kind of crinkly. She does her turn in the leaves, and she lays down, but then all the bugs start wiggling out, so it's not a good nap spot. Then she finds a nice patch of moss. But what's the problem with moss sometimes? It's soggy. So that's not a good nap spot either. So then Mama Lynx decides to climb a tree. She climbs a tree, she finds the perfect branch, she does her little turn, she starts to lay down, and a mama bird starts squawking at her. She's too close to the nest. So Mama Lynx is looking around for her best day off nap spot. She's looking, then she sees the sky. She's a cat, right? She's a forest kitty. So she does a little wiggle, and she does a very big jump, and jumps all the way to the stars. It's soft, it's quiet up there. So the constellation Mama Lynx, or the constellation Lynx, is Mama finally getting to take her nap. There you go. And I know what you've all been waiting for. Here is the working Google Doc of all of our stories. I take no responsibility for these being accurate to mythology whatsoever. They are totally made up. When credit is needed, I do give credit in the document. So it's also it will also be in the paper proceedings. It doesn't work. Why doesn't it work? I didn't do that. Okay, I'll change it and I will get the link. I will get the correct link somewhere else. Man, this is disappointing. Mama Lynx took it up into the sky with her. But I'll fix that and I'll get it out to in the proceedings. So sorry, I apologize that it doesn't work. But thank you very much, and I hope you make up your own stories.
There we go. Mary's hand went up immediately, so give me a second here.
I was curious about what your staffing structure is like at your place and if there's any challenges with training people on having a different theme every single week. Because I'm just thinking about my trainings and I would be like, oh my God, that's so much. So I'm curious how that goes.
So I am the only full-time person, and then I have 2 part-timers. I do the bulk of the public shows and the field trips. But it was actually my part-timers that came up with this schedule. I have not changed part-time staff in 5 years. So they have their own, and this is the great thing. So if you come on Tuesday and you see me do Sky Safari, and then you come on Thursday and you see one of my other staff members on do Sky Safari, the same constellations, you will hear different stories. And that's the beauty of it, because the constellations are an oral tradition. Make up your own different stories every time. So we haven't changed staff in a while, so I haven't had to train anybody on this. I hope I get more staff eventually. And it's gonna be, we need storytellers, and then we'll teach them astronomy later.
Hi, you may have said this already, but I was wondering how long these presentations are and how you keep such wiggly youngins entertained and on topic for that long.
Very good question. So Sky Safari ranges from 20 minutes to 25 minutes. Our longest kid show is a half hour. And that's if I get on a soapbox and start talking about Neptune for a while. Or I get distracted and talk about Mars. No, our kids shows are never longer than a half hour. And with some of the stories, like the southern fish, Volans. You know what Volans is? A flying fish. And Volans ended up in the sky because he and the other flying fish were having a jumping contest. So I put that story in the middle of the 3, and I have the kids show me how high they can jump. And then I tell them about the jumping contest that ended up with Volans jumping all the way to the stars. So then the kids are jumping and they're turning circles and they're doing that. I don't have that for everything. It's actually really funny because farm animals with Aries, Taurus, and Canis Major is like my shortest one, because I don't get into too much detail about that one. Actually, that's one of the ones where they all work together, because Aries has the golden fluff, and Taurus, people try to steal the golden fluff. So Taurus pokes anybody with his horns, and Canis Major barks at anybody trying to jump into the fence to get the golden fluff. So that's actually a really short one. So we kind of change things. And the beauty about my presenters is they can take notice of their audience and be like, okay, we're going to skip 2 parts of that story and still get to the end. So that's the beauty of my amazing staff.
Anyone else have a question? Oh, sure.
Just a really simple one. How many different ways do they jump into the sky? This isn't like incredible. I'm thinking your imagination is broad. That's impressive.
How many ways do the flying fish jump? All of them? Well, okay, no. So like Draco gets thrown up there because he's in a fight. So he gets tossed up there. They're not always stories about how they got there. Sometimes it's just like, this is a thing. Camelopardalis is a great one because he was the very first giraffe to get a long neck. So he gets a place of honor in the sky. Did I say that wrong? Camelopardalis.
That's good.
Yeah. He was the first to get a long neck. Because so if you break his name apart, he's a camel leopard. Because camels have long necks and spots. But he wanted to eat the leaves at the top of the trees, so he's in the savannah doing wacky neck stretches. And he makes his neck long enough to eat the trees. And then the whole savannah is filled with camel leopards stretching their necks to eat the trees. Camelopardalis was the first one to figure it out.
I can share one that I sometimes pull from probably 15 different sources of oral tradition with the bears. If you want to combine a little bit of silliness with a little bit of actual like scientific background for environmental things, I'll talk about how Ursa Major and Ursa Minor have long tails. Sometimes if they can handle it, I say it's because they were grabbed by their short tails and kind of swung lasso style into the air.
Hercules did that because they ate the honey out of his garden.
Ooh. I kind of like that.
Because we have a beehive down the hall.
I then sometimes add, if they're ready for it, to kind of talk about the seasonal behavior of bears and how it how bears will be able to look up into the sky, see the bears with the long stretched out tails, think, oh, that's gotta hurt, and then they kind of are reminded to stay away from humans. So if you kind of want to add a little bit of that, it gets fun.
I love that so much. Thank you.
All right, well, we're a little bit over time, but thank you, everybody. Thank you to all of our speakers here in paper session 2A, and we'll see you all at the Wildlife Park.